For Lesson 10.8, we're talking about probability of compound events. You'll find the number of outcomes for an event, and you'll find the probability of a compound event. Remember that the essential question for Chapter 10 is, how are statistics used to draw inferences about and compare populations? Two vocabulary words on page 482 are compound event and tree diagram. A compound event consists of two or more simple events, and a tree diagram is one method that you can use to solve problems involving compound events. In example 1 on the bottom of page 482, you see a tree diagram. And tree diagrams are really nice because you can visually see how many outcomes there will be available. One disadvantage is that they take a little bit of time to draw out. So for Got It, number 1 at the bottom of page 482, I've already started my tree diagram over here on the left. Shirt 1, shirt 2, shirt 3, shirt 4, and shirt 5 can all be paired with each pair of pants. So if I was going to really take my time, I'd write out pants 1, pants 2, pants 3, pants 4 for each one of those shirts. Okay, but once you start on the tree diagram, you quickly realize that there's a little shortcut. You can simply take 5 times 4 for a total of 20 combinations. Moving on to page 483, at the top of the page we have another strategy, which is to make a list. Again, a really nice strategy for you to visually see, and a nice strategy for you to see the different ways that you can put together passwords or pizzas and so forth. So what I did on this problem for Got It number 2 is that I just said regular is R, deep dish is D, thin crust is T, and then I made 2 different cheeses, one C and one H, and then of course the 5 toppings are 1, 2, 3, 4, and 5. And so I made an organized list over here of the regular with cheese and topping 1, regular cheese topping 2, regular cheese topping 3, and so on. This is regular and the other cheese topping 1, regular, the other cheese topping 2. Then I went to deep dish cheese 1, deep dish cheese 2, and then deep dish the other cheese 1. So this is not only a list, but it's an organized list. I'm not just coming up with random combinations. I'm making an organized list to find out there's actually 5 combinations for each type of crust. And what I have there is a total of 30 total possible 1 cheese and 1 topping pizzas that can be ordered. Another way you can think about that is that there are 3 different types of crusts times 2 different types of cheeses and 5 different toppings, and 3 times 2 times 5 is 30. And we can get our answer a little bit quicker if we understand this fundamental counting principle, which we're coming up to in just a second. On example 3, we're talking about some different situations involving probability, and what you're going to do is you're going to find the probability of each individual event, and then we're going to multiply those to find out the total. For example 3, we're finding the probability of multiple things happening. In this case, we have to find out the total first. So in example 3, the probability of randomly choosing a 5-letter password that consists of only vowels if each vowel can be used more than once. That's an important thing to remember, if things can be reused. So for the first letter in our password, there's 5 letters, A, E, I, O, and U. For our second letter, since we can reuse letters, we have another 5 possibilities there, and 5 possibilities there, and all the way down. So when we multiply 5 times 5 times 5 times 5 times 5, we get 3,125. So the probability of choosing the right password out of all of those 3,125 combinations, it's 1 out of 3,125. The other vocabulary word you have for lesson 10.8 is fundamental counting principle. And if an event M can occur in M ways, and it's followed by another event N that can occur in N ways, you can have a total of m times n ways. Okay, so you can think of that up here. This is event 1, event 2, event 3, event 4, event 5. And for them all to occur and for you to select the right one, you have 5 times 5 times 5 times 5 times 5, or 3,125 possibilities. And then for you to choose the right one, it's one out of that many. And even going back to the 5 shirts and 4 pairs, we have 5 shirts times 4 pairs, which is a total of 20. So the fundamental counting principle, an example here, if there are 4 possible sizes for fish tanks and 3 possible shapes, then there are 4 times 3, or 12 possible fish tanks. At the top of page 484, we have the fundamental counting principle being used to solve another type of problem. And what we're going to do is find out the outcomes first. In this case, for got it number 4, we have number cubes, and we know that number cubes are 1 through 6. And so on the first number cube, we have 1 out of 6 chance of getting a 5. On the second one, we have 1 out of 6 chance of getting a 5. And on the third one, we have 1 out of 6 chance of getting a 5. So the total is 1 times 1 times 1, which is 1, and 6 times 6 times 6, which is 216. You have a 1 in 216 chance of you have a 1 in 216th probability of rolling 3 5s. Now, just to tie that into a previous lesson, that is theoretically. Okay? That is theoretically what should happen. If we roll the dice 216 times, we should get 3 5s one time. But if we actually did that experiment, it's possible that we can roll 3 5s multiple times. It just depends on how we roll the dice. That's it for lesson 10.8. If you have any questions, let me know.